Hello there, children. Today, we're going to work on graphing secant and cosecant. This educational experience is brought to you by your cool scholar of cosecant and secant. That'd be me, Mr. Faust. Alright, so, these are the last two of our big 6 trig functions we've got to worry about. Now, I need to go about graphing these things, but we need to remember a few properties. So I need to remember the following. Secant of theta is just 1 over cosine of theta, and cosecant of theta is the 1 over sine of theta. Namely speaking, we talked about these are reciprocals of one another. That is going to be huge for us when we graph. So first, the first thing we're going to graph is we're going to work on graphing cosecant of theta. Alright, so we're going to graph cosecant. Now cosecant, remember, is dealing with sine. So I put our theta on here because we're going to keep using our big nice points, pi over 2, pi, 3 pi over 2, and 2 pi. Still going to use those, no big deal there. So the first thing I want to do is I want to remember our point. Sine of 0 is 0, then 1, 0, negative 1, and 0 again. This should all be somewhat familiar to us. So I'm going to graph that, and we'll graph that in the light blue color here. So if I were to plot that, I mean, this is something we've all seen before. Set effects optional. Alright, now, cosecant is the reciprocal of that. Well, let's just graph that in the solid red. Alrighty, so here, the reciprocal of 1 is just 1 over 1. Boring. Matches up right there. How convenient. And the reciprocal of negative 1, just flipping it, negative 1 over 1. Or 1 over 1, or 1 over negative 1, it's just still negative 1. Flipping this isn't going to do anything. Alright, that's all well and good. Where we've got a problem is these three. Watch this. This is really 0 over 1, technically, because anything divided by 0 divided by any number is 0. But when I flip this, it becomes 1 over 0, as does these, and this one. And lo and behold, when that happens, folks, I'm dividing by 0, and like you saw with tangent, undefined. Well, what in the world is going on there? How do we put things that are undefined? Well, if you recall, what we do is an asymptote. So I have an asymptote here. I'm not going to draw because there's a solid line there. I've got an asymptote right here. And wow, I have 2 points there and technically 3 asymptotes. Not overly helpful to me. Well, luckily, since I know this is the reciprocal of this, I'm going to pick something that wouldn't be bad to flip around. Namely speaking, if you look at the y values on my unit circle, you'll see that at pi over 6, the y value is 1/2. But since cosecant is the reciprocal of 1/2 is all the way up at 2. That seems somewhat helpful to me. And if I look at 5 pi over 6, again, I'm looking at trying to grab a picture. I know 1 point, I want 2 other ones to see what it's going to do. Between 0 and pi, if I look there, I have at 5 pi over 6, I've got the wonderful and glorious 1/2 again, which is going to be up at 2. So I've got values right around here and here, and I can connect my dots, making sure not to touch my asymptotes. Now I need values between pi and 2 pi. And again, I'm going to 7 pi over 6 and 11 pi over 6 because their y values are 1/2. And I know if I flip them, it'll become -2. Now I know what you're probably saying, why can't I pick other values? And you're more than welcome to, but if you flip ones like, oh, I don't know, pi over 4, that's root 2 over 2. That's swell. Who knows top of their head what root 2 over 2, the reciprocal of that graph's like? Or pi over 3, which is 60 degrees. I want to hit the y value there. Sure, take the reciprocal of root 3 over 2. Graph that. It's doable, but you would cause yourself more trouble because you'd get decimals. So if I look here between pi and 2 pi, taking the reciprocal at 7 pi over 6 and 11 pi over 6, I'm going to get negative 2. And here's what I get. Well, look at that. Which, if you think about it, kind of makes some sense. We're taking the reciprocal of sine. Reciprocal means you flip. Look at our thing right here. I flip that, and now it goes upward. This graph in blue really isn't even there in my end product. I'm only graphing the thing in red. That, folks, is what cosecant looks like. To graph it first, what we'll do is we'll simply graph the sine function and draw asymptotes where we get zeros. And then we connect at the very tips of our peaks, both the max and the min, and draw parabolas based off that. Now, let's go ahead and look at the secant function and see if that similarly holds true. So again, let's look at secant. Now, secant, as you know, is the reciprocal of the cosine function. So again, we look at our cosine values here, and that cosine at 0 is 1, then 0, negative 1, 0, 1. Now this is 1 over 1, this is 0 over 1, and so on and so forth. When you take the reciprocal, because remember, secant is just simply 1 over my cosine value, what's going to happen here, we get a 1. Nothing earth-shattering there. We get a negative 1 here, and we get a 1 there. Now I will graph the, keeping it similar to the last one, I'll graph cosine in blue. Blue, da-ba-dee, da-ba-da. So listen up. Here's a story about this cosine function. We all know it. We all love it. There it is. Woo! Yay! All right, now, again, where I run into some problems, and I'll graph the secant function. Right, where I ran into problems for secant is the fact that this becomes 1 over 0, which is undefined again, which means asymptote time again, and same with this. So I plot these, asymptote at pi over 2, asymptote at 3 pi over 2. Now I have points here. Remember, this blue function is really just a reference for me. When we graph these, you'll be able to graph your parent function and do this. So boom, boom, boom. Now just for our purposes, I need a point between 0 and pi over 2 to figure out where this graph goes. Now remember, since cosecant was y, secant is going to be x. So I'm going to pick a point like pi over 3 over here, because I know pi over 3's x value is 1/2, and 1 divided by 1/2 is just 2. Now again, we know don't cross the asymptotes. Now, over here, between pi and 3 pi over 2, I'm going to go with the x values of at 2 pi over 3, which is negative 1/2, and I am also going to go at 4 pi over 3. Why am I doing that? Because they're both going to be at negative 2 down here. Boop, boop. And over here between 3 pi over 2 and 2 pi, I am going to pick the wonderful and glorious value of, hey, 300 degrees, because that gives me a value of 2 as well. Now remember, when graphing the secant function, the line in blue really isn't even there. It's just a reference for you. Notice how it connects at the maxes and mins, asymptotes are where the zeros go. So, what's this look like in practicality purposes? Let's do an example of how you should graph these things. So let's say I graph 2 cosecant of theta. I know this has no left or right shifting, so I can go ahead and mark my 5 key points: 0, pi over 2, pi, 3 pi over 2, and the 2 pi. Now, what we're going to do to graph this is we are going to graph sine, 2 sine of theta, what I call its quote-unquote parent function. Cosecant is the reciprocal of sine, so I'm going to graph 2 sine of theta. Shouldn't be anything earth-shattering there. We've done that. That should be like, all right, cool. I'm going to graph it with a dotted line. So remember, it's an amplitude, so it multiplies every value I see on my graph by 2. I'm going to do this in a dotted line. Now, why am I doing that? Remember, it's the reciprocal of this. So, everywhere my sine function would usually equal a 0, which are these points, I am going to have asymptotes. I'm going to graph this in, we'll go with a yellow here. This will be in a yellow. So, everywhere I have a 0, there's an asymptote time. Big asymptote. Now, my graph connects at the maximum and the minimum of my sine function or cosine function, whichever one I was graphing, and I just create parabolas. It's that easy. If you wanted to erase the thing in the green, you're more than welcome to. So a lot of people do. But that's what I'm graphing there. The yellow graph is what I have. That is the cosecant that I need. So really, cosecant is just graphing, and secant is just graphing the sine or cosine functions originally, connecting at the max or mins, and putting asymptotes where those values usually would equal zeros. That's it. You are more than ready to tackle any assignment thrown at you now. Oh, happy days, you're here again. Oh, yeah. Go henceforth and do Hooray, America.